for lesson 3's homework, we're going to go over all the circle terminology that we have now learned. So in the diagram of circle M, so remember, circles are called by their center. Various points are located on the circle as shown. List 3 segments that are radii of the circle. So that's anything M something. So I see MR, I see MT, and MQ. So those are all radii of our circle. List a segment that's a diameter of this circle. So remember, diameter goes from one side of the circle to the other, end passes through the center. So that would be QT. Okay, now you could put the M in there, all right? Those are the same thing. Usually it's a lot cleaner to leave the M out. So from Q to T would be our diameter. And then list a chord of the circle that's not the diameter. Well, if it just said list a chord, you could repeat the diameter. But since it says not, then we need to find a segment that connects 2 points on the circle and does not pass through the center. In this case, that's going to be QS. All right, so QS is going to be our chord, connects 2 points on the circle without going through the center. In circle K, points A, B, and C lie in the circle. Which of the following would not be a chord of this circle? All right, so if we were to sketch, we know it's circle K, so that's got to be the middle point. And then if we put A, B, and C just randomly on the circle, the only point that would not be a chord would basically be anything that's a radius. So basically anything that includes that letter K is going to be one that would not be a chord. And you can see from our drawing that KC is obviously a radii or a radius and not a chord. In circle O, points A and B lie in the circle such that OA equals 5x minus 11 and OB equals 4 parentheses x minus 1. Which of the following represents the length of circle O's diameter? So be careful. So what are these both? These are both radii, okay, which are all congruent in the same circle. So therefore, we're going to take the two of them and set them equal to each other. All right, we'll start by distributing there. So 5x minus 11 equals 4x minus 4. Subtract the 4x from both sides. At the same point, we can add the 11. And we're going to get that x is equal to 7. So if we want to find the length of the radius, we'll do 5 times 7 minus 11. 5 times 7 is 35, minus 11 is 24. So that's our radius. If we want our diameter, we multiply it by 2, and we get 48, okay? But it all starts with you knowing that you have to set all your radii in the same circle equal to each other. Number 4, in circle L, points E and F lie in a circle such that E, F, and L are not collinear. So in other words, they're not a diameter because they're not in a straight line. If LE, LF, and EF are drawn, which of the following must be true about our triangle? So it's circle L. So L goes in the middle, and then E and F are just points on our circle. All right. Now it says you connect the 3 of them here to make a triangle. Now it doesn't say what could be true. It says what must be true. And if you recognize that EL and LF are radii, it has got to be an isosceles triangle. Okay. So since all radii are congruent, our triangle has to be isosceles. Okay, so whenever you have a triangle made out of that middle section, you end up with an isosceles triangle. Now, could it be equilateral? Could it be right? Could it be obtuse? Yeah, but what does it have to be? It has to be isosceles. Number 5, given circle A shown, answer the following questions. So list a minor and a major arc that have points L and M as their endpoints. So remember, minor, less than 180, so less than half the circle. Major, greater than 180, more than half the circle. So if we want to list our minor arc, it's just going to be the arc LM. All right, short distance. If we want our major arc, well, that's going to be LNM. Okay, by putting the N in there, it tells us that we're going the back route and that bigger route because we have to pass through N. And then same thing, let's say minor and a major that have L and N. Well, the minor arc is going to be Ln, and then our major arc will be the other direction, so it will be Lmn. All right, so most of those minor arcs you can usually get away with 2 letters. Major arcs typically need 3. And the last one, circle A shown below has points B, C, and D marked on it, with angle DAB being 48 degrees. Segment BC is a diameter. Find all the measurements here. So that's a central angle there. So the first thing it wants us to find is arc BD. Well, we should know that arc BD is the same as its central angle. So therefore, 48 degrees, 48 degrees. So since the diameter cuts the circle in half, all right, we know that these 2 angles together add to 180. So 180 minus 48 gives us 132 degrees. So there's our angle DAC. So now if we look, what's the arc DC? Well, same thing. Central angle and its arc are congruent. So 132 degrees. What about BC? Well, arc BC here is a semicircle. Okay. Semicircle, fancy for half circle, is 180 degrees. What about DBC? So we know that's 180. And we found out that this was 48. So what is DBC? Well, it's the 2 of them added together, which gives us 228 degrees. And then the last one, it wants DCB. So it wants us to add the 132 and the 180 together. And that's going to give us 312 degrees. You also could have done 360 minus 48 and recognize that the 48 was the only part that was not included. But that's how we do some work with our central angles and our arcs around our circle.